Hello, today I'm going to be teaching section 10.6, which is factoring ax squared plus bx plus c. So what's new in this lesson is that a is now going to be greater than 1. What we did all of last week is we factored with just x squared. So all this means is there's now going to be a number here. A lot of the steps stay the same, but steps 4 and 5 create a little more difficulty. So we're still going to write out ABC vertically. We're still going to multiply A and C together. We're still going to find two numbers that multiply to make A and C and add to make B. Step 4 is where it really changes, and our final answer is still going to be written out as two binomials. So let's get into the first example. So we have 5x squared plus 11x plus 2. So again, we're still going to write 5, 11, and 2 out vertically. We're still going to multiply A and C, but now we get 10. So it changes a little bit because originally this number was always 1. So now we're saying, okay, what are two numbers that multiply to make 10 but add to make 11? And your numbers are positive 1 and positive 10. So here, now instead of just putting them under 1x, we're going to put them under 5x. And this is where it says right under ax and reduce. This one does not need to be reduced because if you kind of look at it like this, that's 1/5. That is a reduced fraction. 10 over 5, hopefully you can see, needs to be reduced. So I divide by 5, and I get 2 over x. As I write it out as two binomials, I get 5x plus 1 and x plus 2. To check that you did this correctly, at least multiply the first one out. So 5x times x gives me 5x squared, and the last two, 1 times 2, gives me 2. And that's your sort of quick check that you did it correctly. All right, let's try another one. So we are given 3x squared plus 4x minus 15. So again, 3, 4, negative 15. Multiply them together and you get negative 45. And you say, okay, what two numbers multiply to give me negative 45 but add to give me 4? 45 has a lot of factors. So if you need to write them all down and go one by one, 1 times 45, 3 times 15, 6 times 9, 6, that one's not it. 9 times 5. So some variation of 9 and 5 work, and the 5 has to be negative in order for the 4 to be positive, and everything goes under 3x. So again, look and see which one can reduce. This first one needs to reduce. The second one does not need to reduce. That's not always the case, but in this one it is. So this can be divided by 3, and you get 3 over x. So x plus 3, and 3x minus 5. So we'll try one more on our own. Let's do one where both have to reduce. So 6x squared plus 13x plus 5. 6, 13, 5. Multiply to get 30. So think what two numbers add to give 13. Hopefully 3 and 10 pop into your brain. Over 6x over 6x. So here, hopefully you can see that that has to reduce, and this also has to reduce. It will not give you a whole number answer, but it still can be reduced. So here, divide by 3, and you should get 1 over 2x. And here, you divide by 2, and you should get 5 over 3x. So you're left with 2x plus 1 and 3x plus 5.